All right, for those of you who wanted to continue on these optional examples, we're going to go ahead and start with example 5 that says a kite's diagonals are perpendicular. Knowing this, find the area of the kite below. Okay, so before we get started, there's a couple other pieces of information that you might not remember that we're going to go over real quick. So kites have two pairs of consecutive congruent sides. What that means is 35 inches, this side here, is going to be congruent to the next side, or the side next to it. Because the 29-inch side is marked, that means that we're looking at this side here. That one's also going to be 35 inches. Now I said there were two pairs of those. So we have 29 inches on this side. That means that our last side here, which is next to the 29-inch side, has to also equal 29 inches. All right. The other thing you might not be recognizing here is that this 28 inches is actually referring to this piece of the full diagonal. So I have two diagonals in here. I'm going to have my first diagonal P include that 28 inches. So that is equal to 28 inches plus X, which is the other half of the diagonal, and we don't know what that is yet. And then we have our diagonal Q, which is equal to 2 times Y. I know that both sides are equal to that same amount of Y because when you look at these triangles, I have a 35-inch side and a 28-inch side with one side left over. And I have a 28-inch side, a 35-inch side with one side left over. Two of them. I have two of those. And this is a 90-degree angle because they're perpendicular. So because I have two right triangles that have 35 inches, and then the shared 28-inch side, I know that both parts of my diagonal Q have to be equal to Y. All right, we're going to go ahead and start by finding Y. We have this 35 inches that was pre-marked, the 28 inches, and then this side Y in this right triangle. I'm going to go ahead and use the Pythagorean theorem to find my Y. So I have my legs are Y in 28 inches, so I have Y squared plus 28 inches squared is equal to 35 squared. 28 squared happens to be equal to 784. And that's still added to Y squared. And 35 squared is equal to 1,225. When I subtract that 784 from both sides, that leaves me with Y squared is equal to 441. I'm going to go ahead and take the square root of 441, and that gives me that Y is equal to 21. So now that I have my Y, that's enough information to find my Q. So I have my Q is equal to 2 times 21, which is equal to 42. All right, now I'm going to find my X so that I can find my total diagonal. In order to find X, we have to have already found Y, because that is what outlines our triangle. So I know that this distance here is 21 inches. And now I'm going to use that to find X, where I again have a right angle. So I'm going to use the Pythagorean theorem. I have 21 squared plus X squared is equal to 29 squared. 21 squared is 441. We just found the square root of that, so you should still know that 21 squared is 441. I'm trying to get my eraser to pop up here, and it's not working. There we go. All right, so 21 squared is 441 plus x squared is equal to 29 squared, which is 841. And now I'm going to go ahead and subtract that 441 from both sides. And that leaves me with x squared is equal to 400. When you take the square root of both sides, that leaves you with x is equal to 20. So now I know in my diagonal formula, I have p is equal to 28 plus x. Well, now I know that x is 20. So that means that my total diagonal p is going to equal 28 plus 20, which happens to be equal to 48. All right, now that I have those pieces of information, I can continue to use my area for the kite formula. So I have area is equal to 1/2 times diagonal p times diagonal q. I'm going to go ahead and plug that in. I have 1/2 times p is 48 times q, which is 42. So area of the triangle, when I multiply those, I'm just going to go ahead and do that all in one line, is equal to 1008. 1008 inches squared. All right, on to example 6. In example 6, it says the diagonals of a rhombus are perpendicular bisectors. Knowing this, find the area of the rhombus below. All right, so the rhombus is a little nicer for us where our diagonals are perpendicular, and if you were to cut them where the intersection is, both halves would be equal. So this diagonal is equal to that diagonal, and this diagonal is equal to this half of the diagonal. So in order to solve, we do have to create another triangle here because we're trying to find the area and we only know the full length of one and a side. So if we divide that full length in half, so I have 72 divided by 2, which is equal to 36. That is this side of my triangle. So that's 36. And now I can use the Pythagorean theorem to find this missing side right here, which is half of my other diagonal. So before I forget about my diagonals, I have P is equal to 72, and now I'm trying to find Q, which we don't know yet. So I have, in my triangle again, I have side 36, I have the hypotenuse of 39, and I have my unknown side. So I have x squared plus 36 squared is equal to 39 squared. All right, so x squared plus 36 squared happens to be 1,296, and 39 squared happens to be 1,521. When I subtract that 1,296 from both sides, that leaves me with x squared is equal to 225. I'm going to square root both sides, and that gives me x is equal to 15. Now that I know half of the diagonal, I can multiply that by 2 to find q, because q we don't know, or we didn't know, but we knew that it was 2 times half of the diagonal, so 2x is what we're working with. So when I multiply that out, that gives me 30. So q happens to be equal to 2 times 15, which is equal to 30, to catch you all up there. All right, now I'm going to go ahead and take those diagonals and I'm going to plug them in the formula for area of a rhombus. So I have area is equal to 1/2 times p times q, where in this situation my p is equal to 72 and my q is equal to 30. Although we also just talked about how 2 times 15 is 30, so we can combine those already and jump back to what x happened to have been, which was 15. So I'm really working with 15 times 72. So the area of my rhombus is equal to 15 times 72, which is 1080 meters squared. All right, and that is the end of all of those examples. Again, this video is optional. The focus of our assignment was really on examples 1, 3, and 4, but I wanted to give these to you in case you wanted to go a little deeper in the lesson. So that will be all.